Hello and good afternoon. CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP Route course, and this afternoon's video tutorial is going to be on Discovery Activity number 25 from Cisco Learning Labs. Again, just some fantastic activities here to really solidify your understanding of the topics that we're covering. And so Discovery Activity 25 is going to be on configuring EIGRP authentication, and we also have a Cisco Networking Academy lab that'll be posting here shortly that's doing the same thing but taking a little deeper dive looking at the SHA-256 keys instead of, or authentication, instead of the MD5 authentication. So let's go ahead and dive in here. The first step, it's asking us to configure a keychain named EIGRP_keys. And so let's go ahead and knock this out on router 1. So we're going to go from user exec to privilege exec into global config, and I'm just simply going to say keychain, and we'll call this EIGRP, and it's supposed to be _keys. Whoops. So now we're in the keychain configuration mode. So here I can pick out a key, right? So I can say key number 1, whatever I want to number my key. So I'm going to say key number 1. And now we would put in the key string, right? So I can put in just plain text right here. So we'll put in route is what they're asking for. So that's configuration of the key. So do show run section key, right? There is the keychain. Or if I were to say do show keychain, so there is our keychain, and it shows the text of the key is just route, right? And right now the accept and send lifetime are infinite, or it's valid now forever. So we'll go over here to router 2, and we're going to do the same thing on the companion router here, from user exec to privilege exec into global config. And we're going to say, well, actually not router, sorry about that, keychain, and we're going to say EIGRP_keys. We're going to use key number 1, and the key string is just simply going to be route. So now we've configured the two keys. What we want to do, and it's the same thing here, if I were to say do show keychain, it'll show you what the key actually has, or how the key is configured, or the keychain is configured. All right, so now we're going to configure EIGRP authentication. We're going to use MD5, and I'm actually going to see if SHA-256 is an option. Over here on 15.5.3 code, I wanted to pull this up so that you could see. You can certainly choose MD5. However, this is highly recommended, the SHA-256, HMAC SHA-256 authentication, because this is far more secure than MD5. And so let's see if that's actually an option here, or if the only option we have is MD5. So we're going to jump under the interface. Let's go back to router 1 here. And so under the interface on router 1, I'm going to say interface Ethernet 00, and we're going to go back to this IP authentication and mode and EIGRP, and we are AS100, I believe. And as you can see here, the choice is MD5. That's the only choice we have is MD5. So I'm going to say IP authentication mode EIGRP 100, MD5, and let's see what happens with the adjacency. And you can see that the adjacency with router 2 went down immediately, right? Because we've enabled authentication on one side of the equation, but we haven't enabled it on the other side of the equation. Now, another key thing to remember is this command is entered at the interface level. We are not entering the command in the global EIGRP section. So if I were to say do show run section EIGRP, you can see that we are not going to be entering it in here for IPv4 or for IPv6, right? So we put it under the interface for IPv4. So let's go over to router 2. And let's do the same thing. Interface Ethernet 00, IP authentication, mode EIGRP 100, and MD5. Whoops, sorry about that. And MD5, and then you can see that the adjacency says the authentication mode changed. And now what we need to do is we need to add in our key. So if I were to say do show IP EIGRP neighbors, you can see that we don't have any neighbors right now. So it's very similar if you want to compare and contrast this to when we did the OSPF work. As soon as I went onto the interface in OSPF and I said IP OSPF authentication, it immediately took down, well, I shouldn't say immediately, after the dead timer expired, after 40 seconds had gone up, or wherever we were at in that first 10 seconds of the dead timer, between 30 and 40 seconds, the adjacency will go down, right? With EIGRP, it was instantaneous that the adjacency went down. OSPF, we had to wait a little bit, but in both cases, as soon as we indicate that we are running authentication for either OSPF or EIGRP, we are in danger of losing the neighbor adjacency. So now that we've told the interfaces that we want both interfaces to be running authentication and we want to secure the control plane, the next thing we need to do is we need to associate the keys that we created earlier, or the key chain we created earlier with the keys on it. We need to associate that with the EIGRP process so that we can go ahead and have authentication up and fully functional. So what we're going to do now is under the interface, we're going to say IP authentication. And remember, we saw the mode. Well, now we're going to do the keychain for EIGRP. And you'll notice that we need to match the autonomous system number and then the word of the keychain. So this is going to be the name of the keychain we configured earlier. So EIGRP underscore keys. So on router 2 here, if I were to say do debug IP EIGRP, and is it packets that we want to take a look at? No, here, give me a second. Let me, let's say debug IP EIGRP. Let's see here. Not notifications. I thought that we had packets. There we go. Sorry. Packets and yeah, so we're going to be taking a look at all the packets, and you can see that we got what we were looking for there. And let me go ahead and kill this real quick. All right, and thankfully it gave us exactly what we were looking for right at the very end there. Just like when we did the debug IP OSPF adjacency, when we do a debug EIGRP packets, you can see here it says ignored packet from 10.10.12.1. Well, this is router 1. Well, why are we ignoring the packet from router 1? The opcode is set to 5, which means missing authentication. Because again, we've configured the IP authentication keychain command here on router 2, but we have not done it on router 1. So let's turn this debug back on, debug EIGRP packets, and you can see that what's going to happen is we're going to be rejecting or ignoring the packets coming in from router 1. Packets that we're sending are being sent, but the packets that we're receiving are being ignored because of that mismatched authentication. So now let's go back over to router 1 here, and on that same Ethernet 00 interface, we're going to put an IP authentication. And remember, we did mode EIGRP first, and that broke the adjacencies. Now we're going to say IP authentication keychain, EIGRP 100 for the autonomous system number, and EIGRP underscore key. So we're going to match the key statement. So now what should end up happening is we should see the adjacency come up, and sure enough, it did right there. If we come back over here, let's say you all real quick, and hopefully it's going to let us get that in there and that we have not lost control. There we go. You all, and let's kind of scroll back a little bit to see. Excuse me. And so you can see right here that now what is it showing us in the debug? EIGRP receive packet with MD5 authentication. It shows the key ID as 1, and we are now doing authentication for the EIGRP peering based off of the fact that we've got it configured now on both sides properly. And you can see here that it's actually telling us in the debug that authentication is in fact being used. All right, so if I were to say show IP EIGRP neighbors, you can see that our adjacency with router 1 is back up and operational. So it also wants us to take a look at the debug, and actually we were already doing that with the we already saw the mismatch when we had nothing there. So it's asking us to do the same thing here. So it's asking us to say debug EIGRP packet. Whoops, sorry about that. And the debugging is on, and it wants us to come over to router 1, and then misconfigure. Let's bail out here. We're going to say keychain EIGRP underscore keys, and we're going to change the key. We're changing key 1's value, the key string, to CCMP. So now if I were to say do show run section keychain, and you can see the authentication failure is the reason that things went down, and the key string is now CCMP. And let's say you all kill some debugging here and see if we can go back. And we should have seen, again, right, authentication mismatch right here, opcode 5, invalid authentication, because the keys no longer match. And so that's why we're having the issue of the key strings no longer match, which is why we're having the issue between router 1 and router 2. Okay, and so let's go ahead. And on router 2, we'll make the change here to the keychain on router 2. So we'll go to global config, say keychain EIGRP underscore keys. We're dealing with key 1. And we're going to say key string is CCNP. So now let's watch as the adjacency comes back up, because now the key strings match. So there we go. Up, new adjacency. Do show IP EIGRP neighbors. And as you can see, the neighbor relationship between router 2 and router 1 is back. Now you're probably wondering, okay, well, it's obvious the key string has to match. What about the key number? So let's check that out. So we're going to go ahead and say no keychain EIGRP underscore keys. And I'm going to actually put a different keychain name in here. So let's say keychain, there you go, authorization fail or authentication fail. So we're going to call this keychain, I'm going to call this one keys underscore EIGRP. So basically the name reversed, right? We're going to say key 99, and the key string will be CCMP. So now I also need to make sure I go into the interface. So do show run interface Ethernet 00. So let's get into interface Ethernet 00, and we're going to say IP authentication mode EIGRP. Well, actually, we're good with the mode. We need to change the keychain. IP EIGRP or IP authentication keychain EIGRP 100, and we're calling it keys underscore EIGRP. So let's see, does this fix anything? Does the adjacency come back up? Let's kick our debugs off over here on router 1. So debug EIGRP packets. And so let's see if we're seeing anything here that shows us the adjacency is going to come back up. No, in fact, what we're seeing is we're ignoring the packet authentication or invalid authentication, right? So we know that the key strings need to match. So we've got the right key string in here, right? If I were to say do show run section keychain, we've got the right key string, but the key number is different. So do you think it's possible that it's either the keychain name or the key number? Well, let's jump in and let's do keychain, again, keys underscore EIGRP, and I'm going to say key 1. So let's match the key numbers. Key string is CCMP. So is this going to resolve things? And it does. So here's what we've learned so far. The key string must match. The key number must match. The keychain name is locally significant, and the keychain name does not need to match. So let's go ahead now, and we're going to manipulate the send and receive times, or the send and accept times, for these keys. And so let's go back over here to router 1, and we're going to have to do a U-all here. So undebug all, go to global config, and let's say keychain, whoops, sorry, keychain Eigrp underscore keys. And we're going to go ahead and say for key 1, which is the key we were working with, we are going to set the accept lifetime, and they've got us setting it here for 0000, whoops, 00, and they set it for January 1st, 2014, so that's good. So we'll say January 1st, 2014, and then we're going to put in here the duration. So we could put infinite to have it never expire, but let's say that we're going to have this expire on November, or actually we need a time, sorry about that. So what time does the router think it is now? Do show clock. So it thinks it is 11:34. So here's what we're going to do. We'll go ahead and set this, and we might as well just go ahead and set this out for a while. So we'll say accept lifetime 000000 for January 1st, 2014. So it's good from the 1st of January 2014, and I'm going to say until, whoops, 00, January 1st, or January 1st of 2016. All right. So that's the period, or the window within which we're willing to accept key 1. So now let's go ahead and do the same thing for the send lifetime. In fact, I'm just going to recall this back, and we're going to change the accept lifetime to the send lifetime. And that's our send lifetime as well. Now they want us to do another key, so I'm going to say key 2. And we're going to say key string is going to be, well, let's see what we've got so far here. So do show run section key. All right, so we've got key string CCMP for key 1, and now we're doing key 2 with a key string, and we're going to go ahead and do route. And these may be a little mixed up from what the lab is showing, but that's okay. And so we're going to say the accept lifetime is going to be 224500 on, and they dovetail it there to March 20th. So we're actually going to go until January 1 of 2016. Whoops. And let me make sure I've got everything in here. Oh, we're going to do infinite, sorry. And then we're going to accept that forever. And then the same thing with the send lifetime. So this key is not going to start sending until 2245, and we're not going to start accepting this key until 2245 on January 1st, 2016. And it wants us to go ahead and do the same thing on router 3. Again, we haven't touched router 3 yet, so let's jump in here, go from user exec to privilege exec into global config. Remember, create the keychain name, Eigrp underscore, and I can put in here ABCD, right? Because it doesn't matter. The keychain name is locally significant. So we're going to do key 1, and the key string for key 1 is going to be, I think we did CCMP. We'll do CCMP. And then the same thing. They want us to set the accept lifetime to, whoops, January 1st, and I'll say 2014, all the way up to 23:00:00 of January 1, 2016. And the same thing with the send lifetime. Again, so this is the window within which we're going to send and accept key 1. And this is the the send lifetime. And then we're going to do a new key. We're going to do key 2 with a key string of route. And we're going to say that the accept lifetime, and actually I probably should have just started from scratch. Let's do Control U here. So we're going to do accept lifetime 224500 on March 20th, or actually we'll do January 1st. January 1st, 2016, and then infinite, and then the same thing for the send time. So we're basically doing an overlap here, where we're going to have a little overlap between when we send and accept the keys to transition those keys from key 1 to key 2. And again, if I were to go ahead and say do show keychain, you can see that it's showing me when those keys are valid, it shows they're valid now, and they're going to be valid until January 1st of 2016. So just a little over 35 days away. And then those keys would basically roll off and expire. And so it looks like it wants us to change the keys on the interfaces, or at least for router 1 and router 3. So on router 3, I'm going to go into interface Ethernet 00, and we're going to use the EIGRP keychain names that we use. So IP authentication mode for EIGRP, AS100 is going to be MD5. Whoops. Got my commands backwards there. Authentication mode, EIGRP, 100 MD5. And then on this interface, we're using, remember, a different set of keys. And there you go. You see the neighbor relationship went down right away. But I'm going to bring it back up here when we get over to router 1. So IP authentication keychain, EIGRP 100. And I called this, was it ABC123 or something like that? EIGRP ABCD. Whoops, ABCD. And you're definitely going to be able to see that the names do not have to match in the key chain, right? Those are locally significant names. So let's go to interface Ethernet 01. Whoops, Ethernet 01, and we're going to run the same two commands, right? So IP authentication mode EIGRP 100 MD5, and then we're going to come back and say IP authentication keychain, and this is going to be EIGRP 100, and then the name of our keychain, which here, I probably should have taken a look at this. I think it's just EIGRP keys. Yep. So EIGRP underscore keys, and let's see, does the adjacency come back up? Remember the packets, there we go. Every 5 seconds we've got hello packets flying back and forth. So let's say do show IP EIGRP neighbors. Do show IP EIGRP neighbors. And there we can see that router 1 has both neighbor adjacencies that are up and fully functional, right? And so this is how you do it with MD5. Again, we're going to take a look at using the HMAC SHA-256 in one of the Networking Academy labs that'll be posting up here. I think it's either 8.1 or 8.2. I think it's 8.2 where we do EIGRP authentication. They want us to use that SHA-256, which is definitely more secure than MD5. All right, well, that wraps up EIGRP authentication. Again, remember, we don't do it under the global EIGRP configuration section when we're using EIGRP v4. We do it under the interface, and both commands go into the interface, and we saw some similarities and some differences between EIGRP and OSPF control plane security using MD5 authentication. All right, I'm going to have to change the batteries on my keyboard, it looks like here. Thank you very much for watching. I'll see you guys on Monday, and have a happy Thanksgiving.